Hi to everyone. In this video, let us discuss what is crystal lattice energy and properties of ionic compounds. So first let us see what is crystal lattice energy. So generally that ionic compound is considered as a crystal lattice and it is containing oppositely charged ions. So now that oppositely charged ions having some electrostatic force of attraction. That means to separate them from one another, we need to provide some heat energy or some type of energy. That energy required is known as which one? Crystal lattice energy. So now let us consider one example. NaCl, Na plus Cl minus will combine to give NaCl. At that time, some heat energy will be liberated out. Now that is said to be crystal lattice energy. So two different type of definitions are there. Let us see the first one. The heat energy liberated when 1 mole of a crystal formed from its constituent ions is known as crystal lattice energy. Or another definition, if we provide some heat energy to 1 mole NaCl, that converts into its constituent ions. So the amount of heat energy required to disperse 1 mole of an ionic compound into its constituent ions is also known as which one? Crystal lattice energy. Of course, in these two cases the energy will remain same. How much energy liberated when 1 mole of NaCl is formed? By the same amount of heat energy, we can disperse NaCl into its constituent ions. So, this is the definition of crystal lattice energy. And here, as the attraction in between oppositely charged ions increases, crystal lattice energy also increases. And as the distance between, as the size of these two, that means as the radius of cation and anion increases, that crystal lattice energy decreases because they can have a long bond length. So now what is the crystal lattice energy formula? Let us see here. Crystal lattice energy U equals to K is a constant, K into Z plus into Z minus by R plus R minus. That means here crystal lattice energy is directly proportional to the charge present on the cation and anion and inversely proportional to the radius of cation and anion. So this is the formula to calculate which one? Crystal lattice energy. And what are the competitive questions? Let us see regarding this. So listen here. For example, NaCl crystal lattice energy consider as which one? Means X joules or X kilojoules. Then what is the crystal lattice energy of here? MgSO4. What is its crystal lattice energy? Of course, they give one statement here. Consider cation and anion radii of these two components almost same and neglect the, if any, some changes in radius of cation and anion. So we have to neglect the effect of radius on crystal lattice energy. Now we have to concentrate on which one here? Charge. Now let us see here. What is the charge of cation? Means +1, anion also that 1 unit, that means -1. But here MgSO4 is having +2 charge for magnesium, -2 charge for SO4 -2 SO4. That means here if we are using plus 1 into minus 1 means of course no need to consider our plus and minus. 1 into 1 means 1 unit. But if Mg plus 2 SO4 minus 2 means plus 2 into minus 2, of course that will become which one? 4 units. So now if this I have given which one here x kilojoule and here this is 4 times, that means the crystal lattice energy of MgSO4 is how much means here 4x kilojoules. So like that we need to calculate crystal lattice energy. Okay, then after this crystal lattice energy inversely proportional to which one here? Radii. So what are the questions we can get here? NaF, NaCl, NaBr. What is the order of crystal lattice energy? So as Na is common in all these cases, neglect that and now concentrate on anions. As atomic radii of cation or anion increases, crystal lattice energy what happens? Decreases. So order of crystal lattice energy: NaF greater than NaCl greater than NaBr. And sometimes the question they may give like this: lithium fluoride, lithium chloride, lithium bromide. Here also same, lithium is common in all cases, neglect that. And as atomic size of anion increases, crystal lattice energy decreases. So lithium fluoride greater than lithium chloride greater than lithium bromide. So this is regarding crystal lattice energy of that compounds. Then let us see the properties of ionic compounds. So what are the properties of ionic compounds? Let us see here. So in that the first one is which one means melting and boiling point values. Melting point and boiling point values. All the ionic compounds possess high melting and boiling point values because the oppositely charged ions held together by strong electrostatic force of attraction. So they are having high melting and boiling point values. Example, NaCl melting point is 803 degrees centigrade. Okay, the next property is here regarding solubility. So what is the principle we have to follow for solubility? Means like dissolves like, or like do friendship with like. So like that here, like dissolves like means polar compounds soluble in polar solvents like water, non-polar compounds soluble in non-polar solvents like CCl4, chloroform, benzene, etc. And we know that ionic compounds are having polar nature. So that means here, due to polar nature, that ionic compounds are soluble in polar solvents like water, and they are insoluble in non-polar solvents like benzene, CCl4, chloroform, etc. And one more thing here, when any substance dissolved in water, some energy is produced. The energy produced is known as heat of hydration. The energy liberated when any substance hydrated in water or dissolved in water is known as heat of hydration. Now, the amount of heat energy to disperse an ionic compound into its constituent ions is known as lattice energy. Now one condition here: if NaCl dissolved in water, whether it dissolves or not, that depends upon these two factors. If heat of hydration is greater than that of lattice energy, that substance is soluble in that solvent. For suppose, if heat of hydration is less than that of lattice enthalpy, that substance is insoluble in given solvent, in that solvent. So, as heat of hydration increases or as lattice energy decreases, the solubility of that substance in that given solvent increases. So we have to remember this that thing here. Okay, then this is regarding which one? Solubility. And after that, electrical conductivity. This is somewhat important property related to ionic compounds. Okay. Ionic compounds act as electrical conductors, but either in aqueous solution state or in molten state only, they act as good electrical conductors, because either in aqueous solution state or in molten state, the constituent ions will move freely and they can cause electrical conductivity. But in case of solid state, solid NaCl is electrical insulator. Why? Because solid NaCl is having ions but not having free ions. What are free ions? The ions which move freely, those are called free ions. But in solid NaCl, no free moving ions are present, because in solid state they can't move freely. So a simple example, anyone can swim in water but not on that stones. Like that, in molten state or in aqueous solution state, the ions present in that ionic compound will move freely, they conduct electricity. So solid NaCl is electrical insulator. The reason is it is not having free ions. That is the correct reason. But it is not having ions means that is not correct. It is having ions but not having free ions. That means free moving ions. Okay, that is important regarding electrical conductivity. And another one is here, isomerism or space isomerism. Ionic compounds do not exhibit space isomerism or isomerism, because the bonds present in ionic compounds are non-directional in nature. They are not having directional property. So due to non-directional nature, ionic compounds do not exhibit which one? Isomerism. So these are the that properties of which one means ionic compounds. Okay, in our next video let us see that covalent bond and related properties to covalent bond. Okay, bye.